Hello everyone. In today's video, we will delve into the critical concept of branching statements, specifically if, elif, and else, which serve as the cornerstone of decision-making in computer programming. These constructs enable programmers to direct the flow of execution based on conditional evaluations, allowing for dynamic responses to varying inputs. This understanding is essential not only for developing efficient and responsive software, but also for fostering a deeper comprehension of algorithmic thinking. Okay, so now let's get started with this Jupyter notebook. So the most important thing that we cover in this video is if-else statement. A branching statement, also known as an if-else statement, is a code construct used for conditional execution. It allows you to execute blocks of code only if certain conditions are met. And for doing this, we need to use logical conditions. Remember that logical expressions evaluate to either true or false. And that's what we use for conditions in an if-else statement. So in the simplest case, when you want to use an if statement, you use this if for if, and you put the logical expression here. So this is the one that either is true or false. Do not forget the colon here. That's extremely important. And then here, if you're using Jupyter Notebook, after this colon, if you press enter, you're going to see that you get this indentation. So this is what is very important because we do not use any end and at the end of this if statement. So you can see this if does not have any end later on. And therefore, this indentation is what tells Python what is included inside this if statement, right? That is why we need to use indentation. And here is where you put your code block, right? So here I just put this comment, but this can be multiple lines. You put, everything that you want to be executed if this condition here is true. And if the condition is false, obviously this means that this block of code will not be executed. Okay, so now let's talk about something which is a little bit more complicated, and that's when we can use if-else statement. So similar to before, you're going to use this if and some logical expression. So if this logical expression is true, like what we did before, you're going to run everything that is inside this code block identified by this indentation here, right? You can see the space that we have here from the beginning of this if on the previous line. And then the nice thing about here is that you can use now this else. And remember, you need to, again, use your colon here. And now you have a second block of code. So this means that if that logical expression that we had originally is false, now we're going to run whatever is considered here under this else statement, right? So in this case, whether it's true or false, the logical expression that we have, we're going to run code block 1 or code block 2. But as you can imagine, in some cases, you might have even more complex rules, right? It may not be just as simple as one logical expression that we have to evaluate to be true or false. And in that case, we can use this if statement at the beginning, like we did before, and some logical expression and some block of code. But also you can use elif or elif, and now you can use another logical expression. And again, if this is true, you're going to run this block of code. Although I have to be very careful because once you start with multiple elifs, right, we can see here, the way that Python will interpret this is that the first, and again, I emphasize this, the first true condition that you encounter here determines the code block to be executed. And then the subsequent conditions are not going to be evaluated. So what does this mean? It means that if logical expression P is true, then you're gonna execute code block 1. And let's say logical expression P is false, right? And then you move to the next statement here, and then you check this logical expression Q. And if this is true, you're gonna run code block 2, but you're not even gonna check whether the other expressions that we have later on are true or false. So meaning that you are gonna exit this if a statement that you have. So that's like the key thing here. And I'm gonna emphasize it again that the first true condition encountered determines the code block to be executed, right? So that's something that you really need to remember here. So from now on, we're gonna just look at a few examples to kind of like get some practice, experiment with code, and I encourage you to do the same thing when you're working with these Jupyter notebooks. So let's say we want to create a function called device status, right? Let's say this is for an HVAC system. You have a desired temperature and you have the current temperature, right? So this is the current temperature that we have. This is the desired temperature. And you want to have a function, and we learned about function in the previous lecture, to return a string. If the temperature is less than 5 degrees below the desired temperature, then we should print heat because we have to uh, that's what we need to do. And then if the temperature is more than 5 degrees above the desired temperature, then we should return cool, right? So these are the two main functionalities that we need. And also if we are within plus minus 5 degrees, then it should return off because we don't need to turn on the HVAC system. Okay, so let's run this and see how that works, right? So we have this function def device status temperature. So this is the current temperature, desired temperature with the default value of 65. You can override this if you want, but this means that we don't have to provide this desired temperature later on. Do not forget the doc string or documentation string. That's important to know what this function is for. So this is the first thing that we want to write here for if a statement, right? So we're saying that if the temperature is below the desired -5, then return heat. And something I want to show you, I'm just going to press enter here, and you can see that I already get this indentation, right? So this is what we are talking about, this space that we have here, right? And you don't have to be too worried about it, because if, as I said, put enter here, you can see that we go exactly where we are supposed to be. Okay, so we are saying that if this logical expression is true, then return, or in this case, we have a variable result, and this result, we're going to assign heat to that, right? And then we have this elif, right, that if temperature is above desired temperature plus 5, then the variable result should be equal to cool. So that's what we use for assignment. And else, meaning that if we are somewhere between plus minus 5 degrees, the result should be off, right? I remember when you have a function, right, you always want to return something, especially in this case, since you want to print the result, right, later on. So you're going to see now we can return the result, right? But the value of this result really depends on this if statement that we have here, right? So if the temperature is below something, then it's heat. If other condition is true, then it's cool. And if none of these two conditions are true, then we return or produce off. And you can see that here. Now, if I put temperature to be 40, this is obviously way below 65, right? So when I run this, you get heat, right? And if I put out there like extreme value, let's say it's a summer day, 80 degrees, you see it's now cool. Also, we can try, for example, to put 67 degrees, right? This is very close to 65. As you expect, this condition is not true. This one is not true. So we end up with the else, what we have in the else part of this branching statement, and we get off, right? So please feel free to experiment with this code, and I'm gonna put this back to 40 to get the same result as we had originally. So in that case, it's heat. So in the next cell, what we want to really talk about was this very important information that we had, that if you have this if, elif, the first true condition encountered is the one that really determines which code block needs to be run, right? So let's say we have this function, which I call a check condition. We're going to see whether the value is less than 0. Then we're going to assign negative to result. And this operator here is the remainder after division. So if this value that we provided divided by 2, the remainder is equal to 0, that's why we use equal, then it's an even number. If the remainder by after division by 3 is 0, then it's multiple of 3. And else, we just say other because it's none of these 3 things that we have originally, okay? So let's just start, right? So I can give something negative here, like -3, right? And you can see that we get negative. What this means is that because this is true here, we're gonna assign negative to result, and that's it. We don't have to go and check other uh, logical expressions that we have here, right? And now let's say I use 4, right? So then this one is not true. This one is true because the remainder of the division by 2 is obviously 0, right? But here it becomes tricky. I want you to think about that, right? So what happens if you use 6, right? So let's run this and see what we get, and then we can explain it. So you can see that you again get even. What is that? So again, we go through all these conditions. So this is false. This is true because if I divide 6 by 2, the remainder is 0, right? So definitely, that's why we get even. But you can see even here that because this condition is true, this one, we are not gonna run this next or evaluate this next logical expression. And because of that, we are not gonna get multiple of 3, right? Because we never get to this point. Once we get to this elif and the expression is true, we run this block of code, which is result equals even. And after that, we're gonna exit this function. So we never get really to the rest of these statements that we have here. So we can do many cool things with this type of like if else statements. So let's say, you want to write this like, function for a data science project. And one of the first things you want to know is that once you are given a variable, whether it's the right type or not, right? And then Python actually has a built-in function to do this thing. Similar to the type function that we had before, there is this function which is called isInstance, and the syntax for that is very simple. So you provide an object, you provide the type, and this will tell you whether this object is this type or not. So that's exactly the logical expression that we talk about it, right? So it's either true or false, whether this object is of that type or not. So let's say we have this function process variable, and we have this Docker string here, right? So you have a variable which can be any type, and you want to see whether this what returns is that whether this variable is of one of these types that we have here, right? So we're saying if isInstance variable, so this is the input to this function, is int, then the result is variable is an integer. If this isInstance variable and string is true, then the variable is a string. And we want to also see whether this variable is a list or not, right? So we want to check these 3 types, integer, string, list. And if it's not one of these, then we want to return that this variable has an unknown type, right? So if I run this cell to define this function, so now you can see that you can use this, right? So I'm giving multiple values or inputs to this function, 42, hello, a list, and also something that is, we can run this cell here, but you can see that this is actually a float, right? So it's not an integer, it's not a string. So let's see what happens here, right? So you can see that, yeah, for the first one, we get variable is an integer. So that's for 42. Then we get a string for hello. Then obviously this one is a list and you get a list. And this one, 3.14 is a float, which means that it's not a integer, it's not a string, it's not a list, right? So that's why we get this. Obviously, if you want, here you can have another elif and say isInstance variable and float. and print the type of that variable. But this is what we have here. We didn't want to make this too complicated. Okay, so now we can do even a lot more like cool things for, especially like in the context of like data science, right? So let's say you have an array, a 2D NumPy array. I have to be rigorous about it. And so here you want to find the sums of rows or columns depending on the given input. So meaning that you give the array, and also you can provide the access, whether it's access, rows or columns, right? So that's how you want to write this function, that this access can be rows or columns to show you that you want to find the sums across rows or columns. And also you want to make sure that your function is, in some ways bulletproof. So in the sense that if the input array doesn't have a rank of 2, meaning that it's 1D or 3D or something that is not ranked 2, you want to return none, right? So we had this none before, right? If you remember, which represents the absence of the value, meaning that we really don't want to return any value. So here we import numpy as np. We define our function. I'll call it sum rows columns. So you can give it any name you want. And as we said, we have two inputs, right? Array and access. That's the really nice thing about docstring. You can really explain what these things are. So as you can see, the array should be a numpy nd array, which is a 2D array ideally. And if not, we're going to return none. And then this access here, before you saw that in the NumPy lecture, we use 0, 1, but here we want to use a string, whether rows or columns, to calculate the sum along the corresponding axis, which is rows or columns. And then you return either NumPy array if it's a 2D array originally given to you, or none if the original array is not 2D. So the way that you do this, right, is that you're going to start with the most important thing. Is this array 2D or not, right? So you can use the ndim method to count the number of axes. And if that's not equal to 2, you want to return none. And that's important with knowing how functions work. So when you return something inside a function, means that everything is done. You're leaving that function, right? So meaning that we are not even going to check the rest of whatever is after that, return a statement that we have here. So that's, you can see, if for whatever reason this array is not does not have ndim equals 2, then we return none, and there's nothing really to do after that. However, if ndim is equal to 2, right? So that's the only way you can get after this if statement. If access equals rows, remember, based on the definition of access for NumPy arrays, so now you can use np.sum and set access equals to 1. So this means that now you're going to have these horizontal axis that you use, which means that it's sum across rows, right? And if the axis is columns, then you're going to sum this array across axis 0, which are the vertical axis, which corresponds to columns. And if, like, let's say somebody gives you access where, it's not rows or columns, it's something else, we want to also be like, provide another else statement here to say that access is invalid. So if I run this, we're creating this 2D array, right? Very simple, 1, 2, 3 through 9. The first time I'm gonna use access equals rows, access equals columns, and access equals something else. I call it invalid. So let's print the results of all of these. You can see for the first one, which is the sum across rows, right? So you get 1, 2, 3, which is 6. 4, 5, 9, 4, 5, 6, which is 9 plus 6, 15, and so on. So that the result makes sense, right? The same thing with some columns, right? So the first column is 1, 4, 7, and if we add all of them, we get 12. And in the last case, we get this axis is invalid. So you can see that this if a statement that we have here, it's working as expected. And in this case, if we, let's say, provide a 1D array, right? This is a 1D array, and give it to this function, even though access is valid, is rows, you can see that if I run this, I get here printed none, right? Because that's what the function is supposed to return if you get like, let's say 1D array, right? So definitely the ndim for this is not equal to 2. And we can even check it, right? So if I just use ndim, you can see this is a 1D array, right? It's not 2D. So therefore, once we go through here, we see that we get here 1, and 1 is not equal to 2. So this is true. And since this is true, we return none, right? And that's exactly what happens here. We return none. Okay, the other thing that is very important to know, especially again in the context of being able to write efficient code in data science and scientific computing, is this idea of ternary operator. So what is the idea? So sometimes you have this if-else statement, and you want to write this in one line rather than having these multiple lines of code. So in this case, one thing you can do, I like to read it like in this form, that if some condition is true, right? So this is the one in the middle, then execute whatever it's here, this expression. And if it's not true, means else, then run this part, right? So just to kind of again repeat this, you have a condition in the middle. If this condition is true, then you're going to run whatever is on this left side, right? And then you put the else here. And if this condition is false, then you're gonna run it's on the right side, right? So it's a very helpful thing. So let's say you have like a variable x, which assigned the value of 10. You want to say that, well, if the remainder after division by 2 is 0, right? So this is our condition, then the result is even, else is odd, right? And you can see that it works as expected. So this is really nice, right? And writing if this condition, colon, then true even, and else, colon, then other line odd, right? So that's like really the nice thing about this. And here I show you also one example of this. There's this like module called sys. Especially this sys has a like this sys.version, which gives you a string containing the Python version that you use. So why is this important? Let's say because we do have like Python version 2 and 3. I think these days most people are using Python version 3, but you want to make sure that like, nobody's using Python version 2 in your sort of like code, right? So you import sys, and then you look at this sys.version. I'm going to print it to see what's inside it. So this is what's inside sys.version, this thing. So you can see the first like element here, or if I use index 0, it's this 3, right? So we don't really right now care about these other values here. I just want to see whether this is 2 point something or 3 point something, right? And for doing that, you can look at the first element at index 0, and you can see that it's 3, right? And based on this, you want to see whether the code that you have is machine learning compatible or not, because if it's version 2, it's not, right? So you're saying that if this sys.version, right, the first element, and you can also convert this to integer, because what you get before is a string. If this, when we convert it to integer, is greater than 2, then this ML compatible variable is true, and else it's false, right? So this ML compatible can take on 2 values, true or false. And this value depends on whether this like system version that you have here is 2 or 3, right? So if it's 3, which means that it's greater than 2. So if this condition is true, then we return true, else we return false. And this is very helpful because then you can add this nice like print a statement somewhere in your code and say that, well, machine learning compatibility, right? So this part is always fixed, but you want to say whether it's true or false. And in order to do that, you can just use this ternary thing that we have here. So you can see that if this ML compatible, the one that we found before, is true, you're going to print compatible. And if it's else, which means that it's false, you're gonna print not compatible. So in this way, you really don't need to, use multiple lines of code to do this in just one line. you just check whether this variable is true or not, which really depends on the first element of this sys.version, right? Whether that's 2 or 3, right? As we can see here.